Okay, welcome everyone to our first video. And this is going to be on the basics of set theory. The point of this is really just to give us some very basic vocabulary that we're going to agree on. We're going to start with the idea of what is a set. We're then going to go through a fancy word called cardinality, which is really just a fancy word for size. Then we're going to go over two different ways to make sets from other sets, called intersection and union. All of this admittedly is going to be a little bit of dry, a little bit of abstract. Fortunately, a little light at the end of the tunnel, next video we're going to go over an example from medical testing, where we're going to see that just the simple ideas of size of a set and intersections and unions already allow us to understand a real-world data science example. Okay, fine, let's jump in. So what is a set? As always in this course, I like to give you an example and then work over through the abstract details of what it is. So here's an example of a set. I write a capital letter A, an equal sign, an open bracket, and then some stuff inside the set. So here I'm going to do 1, 2, minus 3, 7. But let me give you another example of a set. Let's say that E is equal to open braces, the word apple, the word monkey, my co-author Daniel Egger, and close braces. Okay, so what can possibly be a general notion that meets these two ideas? Basically, a set is a collection of stuff. Let's write that down. A set is a collection of things. Doesn't really matter what those things are. A little bit of vocabulary. A set is made up of elements. So in this example we have here, the set A is made up of 4 elements. The element 1, the element 2, the element minus 3, the element 7. This example on the right, the set E is made up of 3 elements. The element apple, the element monkey, and the element Daniel Egger. There's really no requirement on what those elements are. A set can really be made up of any things. We tend to use these braces to sort of contain the set. These are the things inside the set. A little bit of notation. When I write something like this, 2 and this funny little half E is in A. This symbol here stands for 2 is an element of A. For example, minus 3 is also in A. However, the number 8 is not in A. We tend to write that by negating that little symbol there. That's what it means to be in there. Okay, fine. The last little notion is the idea of cardinality or size. So definition, the cardinality is just size of a set A is the number of elements in it. And usually we use this notation, absolute value of A. Looks like the absolute value symbol, which we'll talk about later. So in this particular case, where A is equal to 1, 2, minus 3, 7, the cardinality of A is 4. And the cardinality of E in this case, let you think about that for a little bit, is 3. Okay, that's really all there is to cardinality. Fine, let's jump to the next topic. Let me write 3 sets for you here. A is equal to 1, 2, minus 3, 7, as we've seen before. Let's say B is equal to 2, 8, minus 3, 10. And D is equal to 5 and 10. Okay, now you notice that of these 3 sets, they share some elements in common, some elements they don't share in common. There's 2 concepts called intersection and union, which really allow us to talk about those more rigorously. So first I'll just write down an example and then we'll figure out the definition. A, and then this funny symbol here, B. This funny symbol is usually read intersect. This is the intersection of A and B. This is a set which is defined to be the set of elements which are in both A and in B. So the set of elements that A and B share in common. To work out what that is in this case, think it's pretty easy to see that 2 is both in A and in B, and minus 3 is in both A and B, and nothing else is. So A intersect B is equal to the set 2 minus 3. Okay, let's also work out, for example, that B intersect D is equal to the set of things which B and D have in common. And if we see the only element in there is 10. And here's a little funny trick question. Let's work out A intersect D. A intersect D is defined to be the set of elements which both A and D have in common. Unfortunately, there are none, so that set is empty. And there's a special notation for that, which is a 0 with a cross through it. This is called the empty set. Hard to spell. And by convention, we always say that the cardinality of the empty set is 0. There's nothing in it. Okay. And for this really simple example, let me give you a more complicated way of writing it, which will prove fruitful later. Another way of writing A intersect B is to give you a recipe for computing it yourself. So the definition of A intersect B, instead of listing out the elements, I can list it this way. It's the set of X. I don't know what X is, but now I'm going to give you conditions that X satisfies. That's what these little colon here means. The set of X such that X is in A and X is in B. This notation here is very, very important, and we're going to see it over and over again. It's a way of defining the elements of a set, not by listing them explicitly, but by giving conditions they must satisfy to get in. You can almost think about it like membership in a club. This X are the people trying to get in the club. This colon is like the bouncer at the door of the club, checking your ID and saying whether you get in or not. So imagine any X comes along, for example, 2 comes along and says, hey, I want to get into A intersect B. I hear this cool music in there. The bouncer asks, okay, let's check. Are you in A? Yep. And let's check, are you in B? Yep. Okay, you get in. On the other hand, suppose 1 comes along. 1 comes along and the bouncer checks, are you in A? Yep. Are you in B? Nope. And so you don't get in. That's the basic idea behind this definition. Okay, fine. Let's rewrite those sets and give you a different definition. So A is equal to 1, 2, minus 3, 7. B is equal to 2, 8, minus 3, 10. And D is equal to 5, 10. The next idea we're going to define here is the idea of union. A, and this funny upside down intersection symbol, A union B, this is read union. If intersection has the idea of and in here, union you should think of as the idea of or. A union B is equal to the set of things which are in A, or in B, or in both. So it's a much more tolerant condition. So in this case, this will be 1, 2, minus 3, 7. 2 is already in A, so we don't have to write it again. 8, 10. In bouncer club notation, this is a set of X, such that X is in A, or X is in B. Work out another notation. Let's say A union D is equal to 1, 2, minus 3, 7, 5, and 10. Okay, so that concludes our first video. Just to recap what we've learned, you've learned what a set is. You've learned 2 funny ways to write it. One, just by making some braces and putting some things inside the braces. Those give you the elements of a set. And another way you've learned it is by this notation here, which I like to whimsically call the bouncer at a club notation, where we give you a variable X and we say what condition it has to satisfy to get in the set. You've also learned what the cardinality of a set is, and you've learned how to turn 2 sets into intersections, which says what they have in common, and union, which sort of says what they all contain together. That concludes our video. In the next video, we'll see how to use this terminology to understand a real-world example.